Welcome. This lesson is a continuation of our previous lesson over decimals and fractions equivalents. So let's look at our number routine, alike and different. Write down two ways these numbers are alike and two ways these numbers are different. So let's see. We have two rational numbers. Again, what's a rational number? A rational number is a number that can be written in fraction form. So I'm going to make a table. This will be alike, and this will be different. So alike, they are rational numbers. 55 hundredths can be written as in fraction form using place value. Well, what's different? One is a fraction, while the other one is a decimal. What else can I say about this? Using place value, how can I scale up from 20s to the hundreds place value? Times 5 times 5, so that's 5,500. So they are equivalent. So 11/20th is equivalent to 55 hundredths, which is equivalent to the decimal of 55 hundredths. Alike, it's more than a half. They are both a little more than a half. So here's a little joke. I will not let you leave this house looking so improper, young lady. Hopefully you got that. This is, what type of number is this? It's a number mixed with a fraction, a mixed number. And this is an improper fraction. However, are they related to each other? Is 1 1/3 related to 4/3? It is. Again, for those who may have forgotten this, you multiply the denominator with the whole number, that's 3, plus the numerator, 4/3. So 1 1/3 is equivalent to 4/3 because they are a family. That's why the father, 1 1/3, is talking to his improper daughter, 4/3. So what we're going to be doing in this one, I'm going to be numbering off the class 1, 2, 3, 1, 2, 3, and then all the ones will be given this problem. All the twos will be given this problem, and all the threes will be given this problem. They will work together and form a good argument as to why this decimal is equivalent to this fraction, or you could see it the other way around. And then you will share your thoughts with the other groups. So for example, if someone was given this, what could they say? What place value is that in? That is in the tenths place. Is 8/10 equivalent to 4/5? Yes, it is. If you simplify by dividing the numerator and denominator by 2, you get 4/5. Or another way, you could think backward, 4/5. If I using the place value of the tens, 5 times 2 is 10, 4 times 2 8/10. And this is how you write it in decimal form. So what would happen if they were given this one? Is 45 hundredths, I heard hundredths, so let's write it in fraction form. Well, that simplified to 9/20. I can divide both the numerator and denominator by 5 and get 9/20th. Or I can build 9/20th using place value. I can scale up by 5 and get 45 hundredths. And last but not least, the hardest one, 2 and 24 hundredths. If I simplify this by dividing both the numerator and denominator by 4, I get 2 and 6/25. And again, I can build it up by using place value. Multiply the numerator and denominator by 4 and get 2 and 24 hundredths. So each one of you will also be given a fraction, such as 1/3, maybe 7/4, maybe 1/2, maybe 8/25. I would like, using what we learned previously, can you find a decimal equivalency using place value? Yes or no? Can I use place value for 1/3? No, does not go in. I want it perfectly. So no. Can I use place value for 7/4? Yes, I can. I can scale up by 25. So 7 times 25 is 175 hundredths, or 175 hundredths. What about 1/2? Can I use scale fact? Can I use place value? I can use 10 or 100. Yes, I can. The scale factor is times 2 times 2. So, sorry, times 5 times 5. Let me erase that. Make it a little more easier for you guys to see. Times 5 times 5. So it's 5/10. And this is the decimal. Oh, goodness gracious. This is the decimal equivalency. And 8/25, can I use place value to help me here? Yes, I can. Times 4 times 4, that's 32 hundredths. So notice that some fractions can use place value, what others cannot. So today we're going to really focus on what happens if you cannot use place values. So if you cannot use place value, you can divide the numerator by the denominator. So in a fraction, you have 3. You're dividing it into fourths. So this is how you will write it as a division problem. 3 divided by 4. And how do you do it with long division? 3 goes in. You're dividing it into fourths. It'll be 75 hundredths. Or for 3/4, some of you may say, I'd rather use place value. How can I scale 4 to 100? I scale up by 25. I get 7,500 is the same as that. So if you are given a fraction such as 2/5, I would like you to shade in. Here's a fraction bar. Shade in 2/5. 1. I'm going to divide this into fifths. I'm going to shade in 2/5. If you have to tell me, did you shade in more than half or less than half? I shaded a little less than half. Let's make a prediction. If this is a little less than half, make a prediction as to what type of decimal would it be. So half is 50 hundredths. So my prediction is a little like 40 something. So we're going to see. Would you like to use place value, or would you like to divide 2 divided by 5? I personally rather use place value. Would you like to use 10 or 100? I'm going to use the place value of 10. It scales by 2. Scales by 2. I get 4/10. And the decimal equivalency is 4/10. So it goes right here. 4/10, a little less than half. However, some of you may prefer to divide 2. Whoops, let me erase that. 2 divided by 5. 2 is divided into 5 parts. Can 5 go in 2? 0 times. You have 2 left over. How do I get rid of this remainder? I annex a decimal 0. I bring it down. How many 5s go in 20? 4 times. And I get 4/10. Same answer. Next example. So these are terminating decimals. Terminating decimals is when there's no more remainder. It stops. It terminates. 9 divided by 5. So how would you show this using fraction bars? Let's divide these into fifths. Using my highlighter, I am going to shade in 9 of them, 9 of the fifths. So if you had to make a prediction, it's 1 whole bar. Well, let's turn this to a mixed number. 1 whole bar and 1, 2, 3, and 4 fifths. 1 and 4 fifths. So we know that this is between 1 and 2. So it goes somewhere right here. 9 fifths is 1 and 4 fifths. But if I had to make a prediction, what decimal? Well, it's a little more than half. So what decimal would it be? Let's see. This is half right here, so 0.7, 0.8. We'll see. So let's do you like using place value, or would you like to divide this 9 divided into fifths? I'm going to use place value. So, because 5 can go into the place value 10, that's times 2, times 2, that's 18 tenths, and that needs to be in a tenth, so it's 1 and 8 tenths. Hey, I was actually pretty close. I predicted it would be like 1 and 7 tenths, 1 and 8 tenths. Oh, so pretty good. But what if you prefer to divide 9 divided by 5? Can 5 go 9? One time. We have 4 left over. How can I get rid of this remainder? I annex a 0. 5 going 48 times. So we have 1 and 8 tenths. And here's our last terminating decimal, 3/8. So let's divide this into eighths. 1, 2, 3, 1, 2, 3. Let's shade in 3 of the eighths. So is it a little less than half or more than half? From the picture, it's a little less than half, so let's go somewhere right here, 3/8. What decimal would you say? Well, half is right here. I'll say like 0.4, 4 tenths, maybe. Yeah, around 0.4 tenths, maybe. 3/8. Can I use place value? Can I use place value for this? Can I? Let's think about it. I don't believe eighths can go into tenths or hundreds. So I don't think I can use place value. So I'm going to have to divide 3 into 8 parts. So 3 divided into 8 parts. Can 8 go in 3? No, it goes in 0 times. 3 minus 0 is 3. How can I get rid of this decimal? Annex a 0. Bring it down. How many 8's go in 30? 3 times. 30 minus 24 is 6. Annex is 0. Can 8 go in 60? 7 times. 60 minus 56 is 4. 8 go in 40. It goes in 5 times. And that's how we get it. When we learn, so the decimal equivalency of 3/8 is 3 and 75 thousandths. I was kind of close because I did say it's about 4 tenths. But let's think about 3/8. There is a shortcut here. Some of you may prefer this shortcut after we learn how to multiply decimals. Okay, 8 go 100. It cannot. But what if we simplify this and divide both numbers by 2? That would be 1 and 5 tenths of 4. Can 4 go into 100 times 25 times 25? And if you multiply 1 and 5 tenths times 25 hundredths, you should get 300 75. You know what? Let's multiply this. 5 times 5, 25, carry 2. That's 10 plus 2 is 12. 1 times 5 is 5. 1 times 2 is 2. 375. And then is one place right here. But because it's a hundreds, we need to move the decimal 2 over. So that's why it's 375 thousandths. Another way to think about it. All right, next one. I want to share $1, this dollar right here, with 3 friends. How much money will each friend get? Well, let's think. This person may get 30 cents, 30 cents, 30 cents. Nope, that's only 90 cents, so it cannot be 30 cents. 35 cents, 35, 35. No, that's $1.05. That's too much. 33 cents, 33 cents, 33 cents. That's 99 cents. I have 1 cent left over. I cannot, if I give a penny to Curly, Curly will get mad at Mo, and so on and so on. So I need to split that 1 cent into thirds. So it'll be 33 and 1/3 for each person. Well, that would be considered repeating decimal. We're going to learn something called repeating decimal. For example, we have 1/3 here. Let's divide this into thirds. If I shade in a third of it, is this a little less than half or a little more than half? It is a little less than half. And we kind of figure out it's about 33. Can you use place value in order to, you cannot use place value here because 3 doesn't go to 100 place value. So we're going to have to divide this. 1 divided by 3. Can 3 go in 1? Nope, 0 times. Annex is decimal 0. Can 3 go in 10? 3 times. 10 minus 9 is 1. Annex another 0. I know we can get rid of this remainder. Can 3 go in 10? 3 times. 10 minus 9 is 1. Do you notice a pattern right here that this always looks the same? We have a remainder 1. Well, this is called repeating. It's going to repeat over and over. It will never stop. So we draw a repeating bar over the number that repeats. What number is repeating? It is the 3 that is repeating. So you could say this, or you can say this. So that's a repeating bar. Let's look at another example. 7 and 5, 6. Would that be between, what two whole numbers would 7 and 5, 6 be between? It would be between 7 and 8. So it would be somewhere right here. 5, 6. Is this more than a half or a little less than a half? 5 is so close to 6. If you have a fraction bar and you divide it into 6 parts and shade in 5, it's almost a whole. So let's divide this. Can 5, 6, the fraction 5, 6 go into the place value 100? I don't think so. So 5, 6. Can 6 go in 5? 0 times. 5 minus 0 is 5. We need to annex a decimal 0. Can 6 go in 50? 8 times. 50 minus 48 is 2. Let's annex another 0. Can 6 go in 20? 3 times. 20 minus 18 is 2. Let's annex another 0. Can 6 go in 20? 3 times. Now let's stop right here. What do you notice? It's the remainder 2 again and again and again. So it's repeating. But what is repeating? The 8 or the 3? Or is it 83 repeating? It's just the 3. So it's 0 and 83 hundredths. Added to the 7 is 7 and 83 hundredths. So our last example is 1/8. Is 1/8 a terminating or repeating decimal? Explain. Here's 1/8. Can I use place value for this one? No. I predict 1/8 is a little less than half, so it goes right here. So let's divide 1 divided by 8 and figure out what decimal equivalency this is. Can 8 go in 1? 0 times. 1 is remainder. Annex a decimal 0. Can 8 go in 10? 1 time. 10 minus 8 is 2. Annex another 0. Can 8 go in 20? 2 times. 4 is left over. Annex another 0. Can 8 go in 40? 5 times. We are done. So it's 125,000. It is terminating. So our last activity, what you're going to be doing is you're going to be given a fraction or a decimal, and you're going to go throughout the classroom and find your perfect pair. So for example, if someone has 7/25 whole scale factor using 100's place, you'll look around the classroom for the decimal equivalency of 28 hundredths. And if someone gets 12 hundredths, that person will look for the fraction of 1200, which I guarantee won't be there because they did simplify it by 4, so it'll be 3/25. These are equivalent. And that is the lesson over decimal and fractions equivalency. The main thing you need to know is you could use place values of tenths or hundredths, or you could divide the numerator by the denominator, your choice.